All right, in this video we're going to look at questions 4, 5, and 6 on the worksheet, and these all deal with inverse functions. And looking at question 4, it says to consider the function, and here we're just given a list of ordered pairs, and then it says explain why this function doesn't possess an inverse. Well, when asking whether a function possesses an inverse or not, what you're really asking is whether or not the function is one-to-one. Is this a one-to-one function? Well, no, because the output 4 comes from the two inputs 3 and 6. So here we can say that since this function is not one-to-one, it does not possess an inverse. And in the last video, we saw that if you reverse inputs and outputs for a function that is not one-to-one, then the resulting relation is not a function. So just we can say that the inverse does not exist in that case. All right. Question 5 says write down the inverse function for the function, and again here this is presented as a list of ordered pairs. Well, first just check, is this thing one-to-one? And the answer there is yes. Each one of these outputs comes from only one input. And so since it is one-to-one, to construct the inverse, all we do is swap the x and y coordinates, right? We're just swapping inputs and outputs. So there would be the inverse function. All right, and then question 6 says fill in the blanks. The domain of f inverse is blank and the range of f inverse is blank. And you want to have this kind of picture in your head. So if I'm looking at the domain of the inverse function down here, okay, so this set 4, 5, 6, right, these are the inputs for the inverse, so that means they are the outputs for the original function f. And likewise for the range of the inverse, okay, the set 1, 2, 3, these are the outputs for the inverse, so they then are the inputs for the original function f. So put another way, we can say that the domain of f inverse is equal to the range of f, and the range of f inverse is the domain of f, right? It's just a consequence of really the definition of the inverse. It's just swapping inputs and outputs. All right, great. Well, that's a good place to stop. Thanks.